Welcome everyone to MATHurdays. Math's so fun. We do it on Saturdays. My name is Teresa Wills, and I have been teaching online for the past decade. This is my comfort zone, and so I'm here today to share with you how a 1 hour math block might look in your online setting. And the way that we do this in all of these sessions is through interactive slides, which means I am going to share you the link to the slides here in the chat box. And that means that you can actually click into the slides and edit them. I'm going to turn off my screen sharing for a moment, just to encourage you to go ahead and click on that link in the chat box. If you're just joining us, we are clicking this link here in the chat box. And I'll continue to share my screen on the main screen, but in this session, you will move into your other tab that has the interactive slide on while listening in this platform. So I've got some contact information on slide 1, including my recent book, Teaching Math at a Distance. And if you click on that, it'll send you a link if you're interested in learning more. Also, if you click on MATHurdays, there are over 30 recorded sessions from past MATHurdays, which include rich tasks and routines. Many of these are from other sources that I cite within. I try to showcase where people can go to get more rich tasks, where they can go to get more routines. And the full recording is on there, the completed slides, and even the blank slide templates. Also, on slide 2, these are some other bookmarks. If you're looking for just some good templates to use, I keep a variety up on my website. You'll notice they are relatively blank, and that is for your students to do the writing. So when the students are the ones doing the writing, they're showing their learning. And I can already see we have some people typing on slides 3 and 4. If you're new to MATHurdays, first of all, welcome. We have a great community here of some people who come fairly regularly, some people who stop in now and again, and some new faces. And so definitely feel welcome into our community. And on slide 3 or 4, if you would grab a text box and type a success or a celebration that's happening in your world. And to get to a text box, there's a little picture to the left of the slide. It looks like a T with a box around it. And I'll share mine. I got some new problem solving oath stickers. And if you want one, email me with your mailing address and I'll send it to you. I got a little picture of my water bottle where I collect a lot of mathy stickers. And Martha, let's start with you. Tell us about fraction addition and what your student did.
Sorry, I had to get to my microphone. We had adding and subtracting mixed numbers, and this was one of those problems where you had 3 add-ins, and they were all mixed numbers. And normally I would have them find the common denominator of the 3, and usually it's going to be 12. Well, he took the mixed numbers and changed them into improper fractions. And then he found the common denominator. And then he added them, and he came up with something like 67 over 12. And then he divided them, and he got the right answer. And I was like, I can't believe he did it. He got it right. So I was just like, whoa, pretty cool.
And Martha, that shows just how much you have in your class, that ability for students to find their own strategy in their own way. I know that for me, it was really powerful when I had a student put like 2.5 over 5 as a fraction once. And my first idea was like, oh my goodness, what are you doing? This is not the way of doing it. And luckily, I had a really good math coach who was cheering me on as I kind of explored that. So awesome classroom environment. Lisa, I'm noticing in here you said that you can't find the toolbar above your slides. It's possible, and I'm going to showcase it here in Collaborate. There's a chevron all the way to the right. Sometimes we click that and our toolbars kind of go differently. So I can click that down again. And also just make sure that you're not in present mode. If all else fails, closing your window down and trying again sometimes helps out. There's the link. Gosh, there's so many wonderful things on here. Somebody wrote, my celebration is that I'm new to the community. Welcome. Who is this? If you don't mind sharing, we would love to know who you are and what brought you here. And as always, take your time learning to move back to collaborate, turning on your microphone, or you can type it right there. Cool. Let's see. Who is going skiing? Can't wait to get out my cross country skis. Who's that? And what's the weather like where you are?
That's Shanna, and this is Shanna in Portland, Oregon, and we got a rare snowstorm, so not much snow, so we'll see if I can actually get on my skis, but it's gorgeous.
It's so funny when I think about different places, especially places that I haven't been and I only know through like the context I know. I always think of Oregon as being very green and that hops are growing everywhere because I'm a home brewer. So everything I get hop-wise mostly comes from Oregon. But to imagine it with snow is definitely outside of my context that I know of. So how close am I for the way I'm describing your home state?
It is very green usually, right? It is, yeah, beautiful, and then just beautiful with this little dusting of snow.
Very cool. We've even got some more. Harmony, I love this picture of your pup. And so is your pup staying indoors also, or is he pretty comfortable going out and about in that cold weather?
He likes to go outside. He's 14, and so I try to convince him just do your business and come back, but he usually goes to the other side of the yard, and then when he tries to come back, his little paws does like a three-legged hop to get back because his paw is free. So we have to keep a close eye on them so they're not outside too long.
Oh, very cool. Well, I'm glad that he's able to be snuggly with you guys. All right, folks, so this is Successes and Celebrations. I always start out every PD or class with these. It kind of breaks the ice a little bit and gets people more comfortable with using the microphone, and it brings us together as a community. And it's great to see all the connections that we're making to one another right there on the slide. If you're curious about how to do the little like welcome thing or people typing within the arrow, a nice little trick is all of these shape tools, whichever one you want, whether it's the call out, the big burst, or others, you can put on the slide and then double clicking them lets you type right in them. So that can be a nice little way to save some time. Um, Allison and Debbie, it looks like you're getting a little message here. Debbie, would you share with us what you included in your curriculum?
Sure. It's actually aligned to the new IM materials because we're in the beta pilot for that. So we've unwrapped the standards, but a lot of the activities that we've included in it are linked directly to the materials that you would have if you were using that as your teaching resource. So I'm happy to share, Allison. It's not a problem. You may not have some of the things, but that would be released next year in the version 1 and you'd have access to everything.
Love the connections we make in this community. So feel free to message back and forth on that. All right, folks, in this 1 hour block, I usually start off with some sort of a routine. In this case, I'm going to be using the resources from Estimation 180. On slide 5 are links for you. What I'm showing is not a new thing, it's an existing thing, an established thing, and all I'm doing is showing how I would use this in the online classroom. So please click the links to Estimation 180, bookmark them, and this is where you can go to get lots and lots and lots of slides and images for this. If we move down to slide 6, this is the first interaction we're going to do. You're going to assign yourself a color. Usually my students are already assigned, but since I didn't know who was coming today, you'll assign yourself. And if you double click in it, it'll show a cursor so other people know that you've claimed it. And make an estimate that is too low. So over on the left-hand side, what's an estimate for how many marshmallows are in 1 cup? And give us an estimate that is too low. Again, if you are wanting to interact with the slides, the link is in the chat box. Give us an estimate that's too low. And so far, our lowest one comes from whoever picked orange. If you would like to, I invite you to turn on your microphone and tell us why you think 20 is too low.
I think it's too low because I can actually count 20. And so I know there's a lot more than that.
Wonderful. Now that we have some thinking here, go over to the too high side. And I'm going to ask that you stick with your same color. So if you used orange previously, then you're going to use orange in the next one. And if you're just joining us, welcome. We are on this link in the chat box. We're down on slide 6, and we're using an estimation 180 routine.
Okay.
All right. Ooh, these are looking good. I'm very curious about this one. Our lowest too high estimate is 48. And I know for me, that one's getting a little close. So I'm curious, if that was you, I invite you to turn on your microphone and tell us, like, why do you think 48 is too high?
Yeah, what I did is I took the largest ring at the top and I multiplied that by the stack of marshmallows I found. So that was, what, 8 times 6?
And what did that 8 times 6 help you to understand?
Well, I was thinking about it in terms of integration. The largest area would essentially be the cup without the narrowing at the bottom. So essentially, I was taking the largest amount before I would subtract the difference.
That's very clever. So you noticed that it got smaller here at the bottom. I have an arrow showcasing that. And so you said if it was a straight cylinder, it might be 48. So if it's squeezed down, it would be less. Am I understanding that right?
Yes, and my minimum estimate was the opposite. It was approximating how much was at the narrowest part, and then also multiplying by the amount of stack.
Cool strategy. All right, now that you've heard a couple strategies, come on down to slide 7. This is where you're going to put like your real guess. So if you were going to guess how many marshmallows were here in all, what answer would you put in? Wow, these guesses really make me wish that I was in the middle of a mean, median, mode, and range unit. All right, let's hear from this green color. If that's you, I invite you to turn on your mic and tell us why 38.
I just looked at the top and noticed there were more, and on the bottom there were less. So I guessed that there were like 5 or 6, and then there's roughly 3 layers that might be 5 to 6. And then I went down a little bit, maybe like 5 or 4, and counted how many layers, and then just added all those together and got roughly 30.
Neat. I tried to gather most of your thoughts there. If anything on there isn't what you were thinking, feel free to edit it. You have that ability.
Oh,
And
wonderful. Thank you.
Yeah, a little bit higher up, we've also got 46. If that was you in that kind of peach color, I invite you to turn on your mic and tell us why 46.
Hi, I was listening to the other explained how he got the 48, and then I just believe and then estimate it.
I love that you're referencing another strategy that we did on another slide there. So very cool. At this point, I would kind of wrap up our questionings. We have some student voice right there on the slides. Typically with younger kids, I will restate what I wrote and I say, is this what you were thinking? To really honor that student voice. With older students, I allow them to go in and edit their what I typed in. And then next up, we do the reveal. Again, this is a product of Estimation 180. I didn't have to do any extra work. So here is the big reveal. At any given time, it's pretty nice to pause it and let students kind of re-estimate if they want. And I like how he slows down here. So like here, the rest are covered, but you know there's only a few left. All right, we got 44. And do we get any 44s on here? We got some really close. Oh, we did get a 44. Very cool. All right, folks, so the protocols that I used are on slide 8. I never try to say that there's one right way of doing things online, but I also like to showcase like what I did in case that can help you all decide what you would like to do. So first I asked for a too high, then a too low. I made sure to honor student voice by having them describe their strategies before we move to the best estimate. And at this point in the math block, we would now move into a rich task. On slide 9, I have the reasoning why we do rich tasks. If you are a teacher, a math coach, an administrator, or any of the above, it's really important to ground what we're doing in good mathematical practices. And these are NCTM's 8 mathematical teaching practices, and you'll see all 8 here today. So let's see who is ready. I have a problem-solving oath on slide 10. Read it to yourself, insert your name at the blank. And if you would like to make this pledge today, you're going to type your name in the chat box. That's how you can be responsible for it. I, Teresa, promise to try my best. I will make sense of patterns and numbers. I will use manipulatives and drawings. I will make mistakes. I will ask questions. I will listen to other ideas. I will stay engaged by always trying to find another solution or representation. I am a problem solver. I make the world a better place. So if you would like to publicly state that I'm willing to do this oath today, put your name in the chat box. It's great to see so many problem solvers today. And let's jump into the task. This task comes from Enrich Math. It's a fantastic resource. Again, I'm not redesigning anything. I'm showing teachers how to use things that are already out there and doing it online. Oh, I have the wrong link there. Let me go ahead and get the Enrich link on this. So in my family, we're big Legends of Zelda fans. And in this task, it looks at the Triforce, which looks like this little symbol on slide 11. And today you are going to be in triangle world. It's a little different than the world we live in because we measure length, area, and volume using triangles. For example, this Triforce symbol has sides that measure 2, 2, and 2. and it has an area of 4 T's. In other words, 4 triangles. In this case, 3 of those triangles are yellow and 1 of them is white. So each triangle is how we measure area here, and you would say this has an area of 1, 2, 3, 4T. And in this task, you're kind of going to explore to develop generalizations. And from those generalizations, you're going to test them out until you get to the real problem down at the bottom. In a minute, I'm going to put you in groups. Your task starts if you're group 1 on slide 12. You're going to look at these weird shapes in triangle world, and you will identify the sides and how many triangles would fit inside of it. In other words, like length and area. And then there's a place for you to test out any generalizations that you think you made on the next slide. And then you'll do it with triangles, test out generalizations, and then there's a challenge problem at the end. Each group has their own set of slides. If you keep scrolling down, you'll see there's group 3, group 4, group 5, and more. All right, I'm going to go ahead and pop everyone into breakout rooms. So get ready to turn on your mic, get ready to get active on your slides, say hello to other people. It is officially our group time. And you're going to be automatically placed into groups. So say hello and enjoy the task.
Oh yeah. I guess we got to go to group. I gotta set myself up with my double screen.
Hi group, just giving you a heads up that you start on slide 27. So if you want to scroll down there, that's where you can start doing all of your work, and feel free to write on the slides or chat it over together.
Hey, is your email somewhere, Teresa? Because I couldn't find it to get the sticker.
Yeah, here, I'll put it in the chat box. It's my name,
Thanks,
Teresa
hon. Have a
Wills
nice
at
day.
Gmail.
Thank you.
Yeah.
Have a good day.
And slide 32.
Hi group, thank you, Laura. I was just going to say, come on down to slide 32.
Yeah, thanks. Good morning, Teresa.
Good morning.
Good morning, Teresa. Thank you, Laura. I kept scrolling and I was having trouble finding it this morning.
I know. I was like, where are we? There we are. Okay, so we're going to start down on slide 32. So we have a collection of shapes.
So, 1, 2, 3, 4, 5, 6.
This is interesting.
1, 2. We're getting ready to start perimeter next week, so I'm excited.
Right.
Hi group. I hope you enjoy this task, and be patient with yourself, because this task really makes us think about the conceptual reasons about why we teach what we do in area, perimeter, and volume. And be patient as it flips your brain upside down.
Teresa, how did you use something to connect those dots in the model?
I did. I used the line tool.
Okay.
I don't think it's the most efficient method out there, but sometimes with a little dividing and conquering within the group, you can start to notice patterns so that you don't keep having to use the line tool.
Yeah, gotcha.
Mm-hmm.
Thank you. Oh, I just thought of something that could be potentially helpful for us. Like, you see for...
Hi there, group 2.
Hi.
These are looking great. I see that somebody is already typing in a pattern that they notice. And I encourage you to just really be patient with yourself today, because we are going to flip everything you know about area upside down and really make us look at it from a conceptual standpoint instead of like follow this rule standpoint.
Great. Wait. 1, 2, 3.
Hey there, group 3. How's it going? Isn't this a really weird way of thinking about area and the side lengths?
Yes, it's very strange.
1, 2, 3, 4. Oh, you can.
No.
Okay.
Oh, group, that's
Yeah,
all right.
say what I did on the
We encourage mistakes in here. So if you accidentally move something, just hit Control Z and it'll go back.
Sides.
Okay.
1, 2, 3, 4, and 2. 4,
One.
2.
Did she already define that they have to be a certain size? Or do we make up what the triangle is?
I think she did that in the previous slide, on slide 11, where she said this is the unit of measure. And
Okay.
so,
All right,
yeah,
I'll look
like,
back at that. Thanks a bunch.
mm-hmm.
Hi, group. So
Yeah, I'm having
when you
trouble.
teach, oh, go ahead.
I'm having trouble with the line. I'm having trouble with getting the lines to go straight. Is there a trick to that?
Do you have the,
Oh, there it
are
is. That's a
you-
little, there we go. I think I got it now.
So
That's
much
fine.
like
Okay, go
in
ahead,
a
Teresa.
face-to-face class, you know, when we take out things like the base 10 blocks and they're building these numbers, we want them to start conceptualizing in a way that they can visualize it without the base 10 blocks. And I think that this struggle to use the line tool is a great example of that in the online class, that here it's like, I don't want to have to use these lines every time. They're not convenient. And so it's going to force me to start to make patterns and generalizations about the shapes.
That's cool. I think I accidentally got shifted somehow.
Let's see if I can
It's
get
all right.
back to where it was.
I just
There you
want
go.
to know for the first shape, how do you get 2 sides, 2 and 4 sides?
So you're probably thinking of the like Pythagorean theorem and how typically we don't have that angle piece as being 1, but in triangle world, which is where we are, we count units from dot to dot. And so that letter A is 2 lengths long and or 2
Okay.
lengths high and 4 lengths long.
Okay, got it. Thank you.
Yeah, and as you all are filling out the organization on the side, see if you notice any patterns, any tricks that make it so you can figure these out easily.
We have.
And
I
usually
love-
we have fun working together, Laura. You're a good partner.
We do. I love working with you, Colette. Yes, I do enjoy coming back and getting to work with you.
Hi, Carmen. Hi, Lynn. Welcome. Were you all in a previous group, or are you just joining us now? And if so, welcome. I'm going to move both of you all into group 5. They are a lively bunch down there. They'll be happy to include you in the discussion also.
And just, and the bad thing is you get used to the warm weather and then it goes away.
Yeah, I know, and then it's just gone. Our problem right now is that we have snow and they're not giving us snow days because they're like, well, you can just teach virtually. We're like, oh no, what happened to our snow days? We need our snow days.
Hi there, Colette
yeah.
and Laura and Barbara. I've added 2 other people who just came in, Carmen and Lynn, to your group. Carmen and Lynn,
Good
feel free to turn on
morning.
your mic and join in the conversation.
Good
Thanks,
morning,
Teresa.
Carmen. Good morning,
Hi,
Lynn.
everyone.
We're down on slide
Good morning,
32.
Carmen. Good morning, Lynn.
Hi. Actually, I'm a GMU alum, but I heard about this from a friend in Wisconsin. I work at WIDA in Wisconsin now, so I am super psyched to come in. And I'm sorry I'm late.
No worries. Welcome, welcome.
Thank you.
As I tell my students when they come in late, we're just glad you're here.
Yes, exactly. We're down on slide 32. I think Teresa just shared the link, but we can resend it to you if you need it. Did you grab the link? Did you see the link she sent?
I did the MATHurdays. I did it from the login, but I will double check from the chat. I think I have a link. I have 32, and it slides on the right with triangles. Is that?
Yes. Yeah,
right?
we're all the
Yeah.
way down on slide 32, and we just finished where Colette is working on parallelogram B, and we're looking for the relationship between the number of triangles we can build versus the size of the parallelogram.
And Laura just finished on C.
And like everybody has a unique perspective, and we all have a certain amount of spatial thinking. It's just that we're all tackling it in a different sort of spatial mindset.
Hi there, group. It looks like you all have some great reasoning and generalizations. Feel free to head down to slide 13 and test it out. See if you can break your rule or if your rule always works. And there's two things you can use, the polyline tool or even isometric dot paper. So those are available to you all.
Thank you.
Okay then.
And once you got that,
Another
head
way
down
of
to slide 14. Oh, sorry, go ahead.
Oh no, that's okay. Go ahead, Teresa.
I was just going to say, once you think your generalization is right, then head on down to slide 14.
Okay, thanks.
Hi, group 2. I see several people are checking out that new dot paper. I love that things just snap to the grid on that. Go ahead and test out your generalization. See if your thinking holds true.
Okay. One, two, four.
Come in the middle, and I'll watch and listen, and then pick up. So keep going. Yeah, sorry.
Okay. Colette, did you I think you finished parallelogram B, right?
I finished B and I'm down here on G. I just found one that nobody was working on. What are you working on, Laura?
I grabbed parallelogram D because that was a little teeny tiny one. I was like, oh, let's get that one out of them.
That's
You
why
know
I
how it is.
grabbed G.
I was like, I'm going to do two.
I can do this. Looking for these patterns. Oh, wait a second. That's not right.
What? Did I miscount?
I started to draw a diagonal on G, and it divided it incorrectly. It
On
didn't
G?
make my triangles.
Oh, you know what though? Because I see what you mean. Like you were going to go do a diagonal left to right.
I was going to do a diagonal going from the
bottom left to top
left
right.
corner to the top, and then it dawned on me I can't do that.
Yeah.
Which is
You can only it won't work because that center vertice, like that dot, doesn't split. Like you'll make quadrilateral. Huh.
It's just an interesting observation. I just went, whoa. Because I started to do it, like I said, and then I just went.
So how many? I feel like I missed 1, 2, 3.
Hi there, group. This is group 3 again. Can you all hear each other?
You know, I
Yes.
figured G was simple, and it actually is a little more difficult than I thought it was going to be.
Right, because you end up making quadrilateral.
I can still hear the other group.
Okay, let's see. Is anyone
Quadrilateral.
into? Oh, it's because we have
Like,
Barbara
yeah,
in
now
both.
I'm just-
I'm going to take you out of this
I
one.
mean, I'm making more parallels.
There we go.
Oh,
There we go.
Yep. Sorry about that. I'm glad we got that figured out. Hi. So how's it going? It looks like you're able to kind of check out your generalizations there.
I think so. It was
it was very hard.
Yeah, it was hard to focus and think when you're,
Yeah.
you know, kind of listening
Yeah.
but not listening, and yeah, so that was
Trying
that
to
was
figure
hard.
out what's going on. Yeah.
So sorry about that. I'm glad you let me know. If that ever happens again, you know, I'm pretty quick at being able to try new things at this, but neat. So whenever you're ready, you can head on down to slide 24 and you'll be able to see if the
Okay.
ideas and generalizations that you made, if they change for these kind of triangular pieces.
Okay.
Teresa said this time identify any two sides that are whole numbers. So it really doesn't matter which two, just ignore the third.
Yeah, so the third one doesn't always use whole numbers, so you're not going to look at that one. You're only going to look at the two sides that do contain whole number lengths.
Okay. Okay. So basically the diagonal, don't worry about that. Got
Exactly. Mm-hmm.
it. Two. Let's see. Come on. One.
I wonder if we can use that generalization to predict F because that's the one we haven't done yet. So
Okay, so it's,
if we could predict F, F is 3.
So 3 times 3 is 9, so it should be 18.
Yep, because 3 and 3, and then double that to get the number of
And
triangles.
then H would be, hang on,
1, 2,
2
3.
and 3 is 6.
2 by 3, 6.
So
and
it should be 12.
Yep. All right. I'm almost done with H, and then we can count it and check our generalization against. Right. I've almost got H done.
Hi there,
I'm going to
group.
write it up just in case.
When we come together as a whole group, I'm going to ask you to explain how you were able to guess the number that were in F and like what your generalization was, because you articulated that so well.
Awesome. We'll be ready.
Great. And then once you kind of got the hang of this, feel free to move down to slide 34, where then you'll check out triangles.
All right. Color.
Have you guys both been to this a lot?
I've been to a couple.
Yeah, they're fun.
First time.
Oh, nice. Welcome.
Thank you.
Hi, group. So these triangle ones get a little bit tricky because sometimes they don't line up nicely. When you count the sides, you're only going to count 2 sides and pick any 2 that make whole numbers. So like in B, you won't want to count that side that's
on slide 20.
wonky.
You're on slide 29, right? Teresa, you're on slide 9, right?
I'm on slide 29.
29.
And for
29, okay.
triangle B, you won't count this wonky side because it doesn't make a whole number piece. So we're going to stretch your mind and see how can we find area of triangles in Triangle World.
Triangle World. Very interesting. Yeah, because it makes a funny shape, D. That's
Yeah, I see someone
because
working
they're
in
not all this.
D.
They're not all this. All they're not all the same side. The other ones, the lines were almost. The lines were more the same size.
So how might
I
you
think they
do
were.
D? How might you kind of see about how many would fit in there?
I don't know. I honestly have no idea.
We could probably count the whole, like how many whole units we have, and then see if we can take the pieces and rearrange them to create another whole triangle.
Oh,
Unit triangle. Estimate that
that's
way.
a good idea.
Next kind of the opening of the estimation 180 where we're estimating. So that might be something to try.
My kids love estimate. My students love estimation 180.
I don't know who's working on C, but if you use
Jennifer is.
if you used what we did on slide 22, that we should have 1, 2, 3, 6, 12 triangles. So half of that would be 6. So that shaded in C should have 6.
6. There. So 1,
Hi,
2,
group.
3, 4, 5. So yeah, I think it's half.
Yeah. It's
Okay.
it's the
No.
it's
Yeah.
the two whole number
thinking,
slides.
yes, I'm thinking half of what we had done on slide 22.
Yes,
That's where I was thinking.
If we extend it out like we did on B, it's half of that amount, which is what we were doing on 22. But it's the two whole number sides multiplied together give us the number of triangles.
Where can you overlap? Where can you make the math easier for yourself? Right.
Hi, Group 1. Wow, I can really see you working hard to test out your hypothesis. Were you able to break it, or do you feel pretty strong in your original thoughts?
So we talked about using odd number sides because the parallelograms that you provided us with had even sides. So I really wanted to know if our generalization worked with odd, and it did with almost all the ones we did. Or we double the one side and multiplied with the other side, we get the number of triangles. It's kind of cool.
That's wicked cool that you thought to do it with the odd numbers there.
You're making me think, Teresa. I gotta test our theory.
Oh, good. I like to flex that brain muscle.
Teresa, I don't know how many emails you get a day, but I will email you for the stickers, but I will send you an image of that fraction problem that student did.
Oh, I'd love to see that.
I took a picture of it because I was like, what was he doing? And I'm like, wait a minute. And I had to really look at it. And then I'm like, wait a minute. This makes sense. I'm like, he did it right. And he may have used a calculator, but it's an SOL that you can use a calculator on. So I just never teach that unit with a calculator. I just think it's way above their thinking.
Yeah, I would love to see that.
Yeah, I was just floored, like, oh, well, this is amazing that he did it that way. So
What I like most about this is how we end up thinking like our students will think and discovering what sort of challenges they might face. Like, I think it was Praha, I'm sorry if I got it wrong for who said this.
What grade level do you see this being? Because it's not third. I mean, it could be.
Right.
I could see this 6th grade in Texas. That's kind of the last place that we do basic area perimeter concepts. And then once they move up, you're looking more at surface area and volume. And so this would be the last stopping ground for basics. I like this activity though.
Like with 7th and 8th grade remediation classes, if they had a second math class, I think
True.
this would be one.
I agree, yes.
Classical geometry, do exploration. Okay.
I could see it doing it with regular shapes, like squares with kids and, half a
Yes.
square. But that's about it in third grade, I think.
Yeah.
Yeah.
Hi, folks.
But
Just
it
a
would be a
heads
good
up. I'm
explanation.
going to be pulling everyone back here in a couple seconds, so you're going to have a whole lot of other folks coming in. I always like to let you know so that you're not caught off guard. Hello, welcome back. Welcome back, everyone. Hello there. We're all back together. Feel free to mute your microphone to give yourself some privacy from any other background noise. All right, so first of all, welcome back and big pat on your back for the amount of productive struggle that each one of you all showcased here today. At this point, I'm going to transition into the math talk, something that I find incredibly important whenever we are doing math problems. And I'm on slide 52. This is what I use for my math talk, Smith & Stein's 5 practices. I've already anticipated, and thank goodness, Enriched Math already had a lot of ways to anticipate, so a little less work on my end. I monitored and saw the different representations that you did. I talked with you all and questioned you all in your thinking. I selected 4 different things that we're going to talk about today and sequenced them in a purposeful order. And now I'm going to try my best to connect them. And we are going to start off with Group 5's work. And they are going to tell us all about letter F and how they were thinking about letter F. I'm on slide 32. You can follow with us and collaborate or on the slides. And Group 5, what did you do with letter F?
Good morning, Teresa. Our group, we were starting to notice that there was a relationship between length versus width. And Colette noticed that if you multiplied length times width and then doubled it, that would give us the number of triangles in the parallelogram. So we decided to test out our theory by predicting the number of triangles we'd have in F, because if we multiplied 3 times 3 and doubled it, that should give us the number of triangles.
Very cool. I would love for everyone to try and think about if they had the same idea of yours or different or in a different order. So I'm going to give everyone an opportunity to do a chat waterfall here. That means you're going to go over to the Blackboard Collaborate, open the chat box, and type in your rule for finding the number of triangles in F. But don't hit enter yet. Let's give everyone enough wait time and we'll all hit enter at the same time. Let's begin our waterfall. If you need more time, feel free to take it, but if you would like to hit enter now, go ahead. I use the chat waterfall both for accountability and for supporting students in gaining confidence to get their ideas out there. When your idea is mixed in with 30 other people's ideas, you don't feel so much on the spot, so it allows that. And right here, I could spend the rest of the time talking about how these different representations are similar and different. But the reason that I'm going to move forward is what I've selected and sequenced. Group 1. Let's talk about the way that you tested your generalization. I'm on slide 13 and Group 1 did something a little different. Would you tell us what was important for you to try and test out?
can speak, and I want to share. So on group, I was going to say I want to share basically what Raha brought into our group discussion, that she noticed on slide 12 when we were playing around with the parallelograms that the sides all were even. Well, something was even there, not everything, but we were talking about how there was a lot of evenness there. So we just wanted to make sure that when we had odd numbers, that we would get the same type pattern, or the same generalization, which the one that we really honed in on was if we take the top, the length of the top of that parallelogram and double it, and then multiply it by the other side, the width, I guess, and then you'd get the number of triangles.
And I love showcasing that you all saw something that was missing in it. It only included evens, and so you wanted to test out odds. And that's where we're thinking like mathematicians. That's that reasoning and proof area that we're always trying to access with students, but might not have the exploration type of an activity for it. So thanks, Allison, for sharing that. All right, we're going to get into the triangles, which was kind of the, we started down in most states have learning area in around third grade, and then in around sixth grade, you start to look at different shapes and the areas and how they're related. And so I'm going to start off with group 4. And group 4 was looking at shape D, and they're on slide 29. So group 4, would you give us a sense of how you started finding the area of shape D on slide 29?
Sure. So we took shape D and we subdivided it into the unit triangles. And then the dots in the triangles represent whole units that we counted. And then we started to look at, okay, how can I take partial pieces and maybe move them around? That's what the color-coded arrows represent. So if I took the little gray piece in the bottom left corner and moved it to the top right corner, I would get another whole unit. And so that we can start adding those partial pieces to create unit triangles and counting the holes.
Really cool. I almost think about this as a puzzle piece, the way you described it. I see other people making connections in the chat box because these triangle pieces were rather annoying, weren't they? They weren't lining up other than A, man. That was tricky. And let's connect it with the thinking that group 3 did on their triangles. They're on slide 24. And I want you to think about how group 4s and group 3s are similar and different. So slide 24, group 3, tell us, how are you thinking about these?
I guess we had a similar thought. We were having trouble kind of counting up full units of triangles, so we thought about extending it out to create a parallelogram, and then it connected to the work we had done on our first slide with looking at doubling the side lengths. So then we realized it would be half of the side lengths if we extended it out to create the parallelogram.
Oh, wow. So you just turned it into a parallelogram because you already had a rule for that. Let's see everyone else. Let's try this out for letter D. Go ahead, grab your scrap paper and pencil. If you made letter D a parallelogram and you applied your rule, is there a way you could predict the area of letter D? Go ahead, try it out. You're welcome to put your responses in the chat box. If you had an aha moment, you can show me with an emoji. Can you do this for letter D? So folks, this activity, I would then take out several days, but I wanted to showcase here some of the things that we talked about. This project really starts in around grade 3 because when we are finding area of square and rectangular figures, students start by counting each little square that's within there. And they develop this idea of length times width. But it's kind of arbitrary unless they really understand the conceptual reason of why it's length times width. And here today, because you are working with triangles, it forced your brain to think about the conceptual understanding of it and where those are coming from, which is a very necessary step for our younger kids who are just learning this. As you moved into testing out, does this always work? That's an important thing that we want to allow our youngest kids to do also. Is multiplication the only thing that works? Could you use other things? And that's where we get into repeated addition and even the distributive property. Finally, with the triangles, around middle school, students get into finding area of trapezoids, triangles, parallelograms, and more. And I think that by doing this activity first, it moves us into a different setting where we're trying to unpack triangle world and make these connections so that we can do the same thing using triangles, which are 1/2 length times width. And today we talked about filling the space and subtracting out half. We talked about rearranging the puzzle pieces, decomposing the whole, and more, which are all concepts taught from 3rd grade through 6th, 7th grade. But I'd like us to think even further. Come on down to slide 53 or 54 or 55. Go ahead and find yourself a space on those. Let's go into 3D world. What if triangle world went 3D? What generalizations could you make about how to find the volume of a pyramid, a triangular pyramid filled with triangular pyramids? What generalization would you do? I see some people asking, would length times width times height work? Great thing to ask. Somebody else is thinking about it in layers. So if we were to cut it off, what would be in each layer? Someone else is asking, is it 1/3 of a cube? And thank you, Allison, for writing in the chat box that this is making your brain hurt because this is really flipping our brains upside down and making us think about all we know when it comes to perimeter, area, and volume. And even though we can't see all of the triangular pieces in this pyramid, we know that there's some inside. And that's the exact thing that our students struggle with when we make a 3x3x3 cube, or like a Rubik's Cube, and there's that hidden one in the middle. And how do we express volume in that way? So I hope you all took something that you can use in your classes. I do hope that we give students access to these really tough problems that make their brains hurt because there was a lot of reasoning and proof here today. I'm going to go ahead and finish this at the top of our hour. I'm on slide 60. If you all have any questions, I'm happy to stay after. If you want to see other topics and grades presented, if you put it in there, I will add it to my list. I have a lot of fun doing these and showcasing others. Again, this comes from Enrich. It wasn't my task, but I hope you saw ways that you can use it online. It's been a pleasure, everyone, and hope to see you on another Saturday for MATHurdays. Yeah, sure thing. I had a great time. Oh, whoever wrote that in there, that made my day. It said, I'm left feeling curious about the triangular pyramid. I'd love to have my students leave feeling the same. And isn't that just one of the best things about teaching math is when we're not quite finished, we're still thinking about it. And I bet when you are cuddling up under a blanket watching this ice storm, you're thinking about that pyramid more. And that's just such a great thing. Feel free to make a bunch of little pyramids and put them together and show me on Twitter what it looks like. Oh, Allison, I'm glad that we can continue to think and ponder. I think I need to add this one in the geometry class. Oh, someone said they were removed from the chat and couldn't get back in. Not really sure. Happy to try and figure it out with you if you want to put your name in there, whoever that was. Oh, whoever wanted to know about like where did I find this task? Again, I try not to create too many new things. I find that that's intimidating to teachers that like not only do I have to teach online, I have to use new things. So instead I try and use resources that I know are fabulous. Enrich is just such a great resource. These things always make me think, and this is the task. Um, and then I went to more isometric areas, and that's where I got the triangles from. And so if you want that task, I'm going to go ahead and put the link in the chat box. I'll also put it on that slide. In terms of how did I create it online, I think that's just, I try to honor student voice and that they are the ones to be the ones thinking and typing. That's my non-negotiable when I teach math, and I just try and keep that front and center, and then try to make things around it. Yes, Allison, I was thinking the same thing about locking the isometric paper. If I went back into this again, and I might even do that before I put the slides up there, because that was definitely moving on more than one group.
So Teresa, this is Lynn. I had a question that came up, and what I realized is I'm on a Mac, and I could not see the parallelograms. And then what I did was I downloaded the PowerPoint just to cross-check it, and when I did it in a PowerPoint, it would show. So there was some type of interaction where my visual, when I was looking at the Google slide, I couldn't see the A, B, C, D. And so I'm wondering if this ever happens, if this is a setting. Is this like a Mac issue getting in? Because I can see it, I guess. Does that make sense, what I'm saying? Sorry, I should stop.
I think I understand the problem, and I've never seen that before. Anyone else with us that's still on using a Mac?
I'm using a Mac, and I didn't. Which slide are you looking at that you had trouble with?
I was looking at 32, and I did a screenshot, and I wondered if I could upload it and show. And I'm sorry, it's been a while. I haven't used Blackboard since I was at GMU, so I just had to remember where to upload a slide I could show.
Yeah, pop it on slide 61. I'm always interested in being able to troubleshoot.
Okay,
Yeah,
thank you so much.
Is your Mac new or is it old?
It's a MacBook Pro. It's probably a couple years old, but not too old.
You're still able to you're still able to update all of like the latest. It will still let you download because my old Mac stopped letting me download like Safari and stuff.
Yeah, no, that's not an issue. So that it's updated.
I don't know. I don't know, but I don't know what you're seeing, so I'd have to look and see.
Yeah, let me insert it on the next slide, and I'm just going to pull it up from my desktop.
Let me know what slide you're on, and I can take a look. We're on 32 right now, right?
No.
Lynn was in our group, and she shared. I asked her to share her screen with us in our small group in BBCU. So we got to see her screen. Essentially, she had everything except for the overlay of the parallelograms. It was really weird. I use Google Slides with my kids, and I'd never seen anything like it.
That's weird.
Yeah, yeah. I'd never seen anything like that.
So yeah, it was really weird. So I'm
I know why
one
that's the
slide.
case.
I'm at the very
Are you in
61.
So that happens occasionally if you are in a school division login and their firewall prevents my images because I'm outside. That's a setting that your school, are you logged in with your school, like Google password and whatnot?
No, I think I'm logged in with my personal one.
Oh, well, then
so
that's
yeah,
totally
I'm
new.
looking at the right hand seat. Yeah,
Weird.
so yeah, and I'm trying to upload my image to slide 61. So I just inserted it.
I can see it
Now
there.
I'm just
I
curious.
see it.
You see it? I can't see it.
Yeah.
Okay, wait. Okay, so that's my screenshot.
So when it's missing images, it's usually due to a firewall issue. So basically, that's not something I really see too much in the classroom because you're like all within the same school division. I only see it when I'm in these kind of anyone can come in sessions. And so one of the things that your computer or your settings are doing is it's not trusting images from outside sources. Even though you just plugged this one in here, it's not trusting it from me. So somewhere in the settings, you have some high security on there. I'm happy to troubleshoot that one more with you. I don't know a ton about it, but I do know that when I'm working with teachers from my kids' district, if I send them something from my personal account and it's not within their district, sometimes the images will go away because of the firewall.
Okay. And I'm logging in my computers from University of Wisconsin, Madison. Okay, and I work at WIDA, and so we just came out with updated standards, and we talk about like the math argumentation, but for multilingual learners. So I'm looking at this going, first of all, I love this, what you have, and I'm like, how do we connect to what you're doing, and like how do we? So I guess I'm just looking at this. I really want to try to do this. This is so cool. And how could we how can we support you?
Yeah,
In what you're
so
doing.
Lynn, let me introduce
Anyways,
you to two people that come to MATHurdays, I think every single time. Laura and Raha, meet Lynn. Lynn, meet Laura and Raha. Y'all got a lot to talk to each other about. If you want to exchange information, I think you both would get great resources from each other. Feel free to also chat now, but definitely wanted to make that connection.
Oh, yeah. So yeah, I work for WIDA there. Let me put my I'll put my email in the inbox. And
That's
I'll put
insane. Teresa, you're too kind. Lara and I just try to put in staffles for our kids because Lara has like level 1s and I have kids that are from 2 to like 6. So we do have a variety. But that's so I've never met anybody that works at WIDA, and this is just crazy in my mind because last year we were all like, we got to make their language levels grow, and that was the goal. But this year it has been a mix of like being a digital citizen and a language learner. But yeah, that's so cool.
So we updated the standards. So we have now like they're organized around 4 key language uses. And for mathematics, it's it's primarily like for the older grades, it's mainly we do prominent key language uses. You have argumentation and explanations. So so the question is like as these standards roll out it's a 3 to 5 year rollout. So we're doing the world's slowest rollout because of the pandemic. But we still had finished the update. And so they have stable, instead of model performance indicators are stable, sorry. And so I'm connecting to Teresa, what you were showing. I'm like, I love it so much. And so it's like, how could we connect and support? And yeah. Oh, you're in Fairfax County. That's where I taught at Bailey's. Oh,
we teach at Bailey's.
No way, this is for real. Are you serious?
Oh my gosh, yes, Laura and I
No.
teach at Bailey's. We teach 4th grade. I'm very lucky to be
Oh
in
my
this.
gosh.
Yeah. That's
Oh
so
my gosh, so
crazy.
Juno Suzanne and Cafe. Yeah, I taught there through 1998. I hate to say.
Laura knows a lot of the people. I'm still new. I've been here for 7 years, so I still think I'm new to Bailey's, but Laura has been at Bailey's for a long time. But I will tell you that coming to Teresa's class has opened up our minds in lots of different ways, and we love that she keeps the slides so open for us to start somewhere. And our kids who are more proficient with their language domains, we're like, okay, you can handle less directions, but for ELL kids, we put in scaffolds, we put in directions, and they still can handle it. They totally can. They love it when we don't give them as many directions.
Oh my God, I love this. This is so awesome. Oh, Bailey's. Oh, that's so good. Wow. Oh, we have to talk. Like, this would be so fun. And because I look at this and I'm like, oh, the interaction is great. You taught CAS kids. That's hilarious. Teresa, I went and got my doctorate at George Mason. So,
Very cool.
but I didn't take a math class. Oh,
Yeah,
but I
so
was in class.
definitely, I can't stress how much I hope that this connection is beneficial to all parties here. But Lara and Raha, I gosh, think it maybe come to every session, all like 37 or something of them, and always bring just
Oh,
this new perspective. And the slides that they share on Twitter are just, it's so great to see that this type of interaction is for all kids. It's not just for kids who are proficient in English. It is for all kids, and that interaction is just so beneficial for learning and problem solving. So, uh, yeah, hope you connect and can go change the world for the better.
yeah, I was told about this from someone in Wisconsin, a colleague who does trainings in Wisconsin, and she's now taking the slides you did and she uses them when she does the grad courses she's doing. That's how she's interacting with her students.
Mm-hmm.
Like she said, she was so excited. Like she was like, this is the best thing since sliced cheese. Wow. And then Meg, where are you located? Help me.
I'm in Vienna, Virginia, or like Fairfax County. I go to George Mason, and Dr. Wills is my professor for our advanced methods course for teaching math.
Awesome.
Yeah, so Meg is one of our
I really
pre-service
enjoy it.
teachers and joining us today as part of a 1-credit what do you call it, independent study. And so she's interacting with a bunch of in-service teachers to gain more knowledge on that.
Wow.
I really enjoyed it. Thank you, Dr. Willis,
Mm-hmm.
for this opportunity. And I think that we were all in the same group, Raha, Lynn, and myself. And it was just so interesting seeing all of our different ideas for how to view the problem. And I loved like seeing the different mathematical minds at work, the different perspectives.
I noticed somebody
Let's
wrote on
see.
slide
Oh my God.
59, they're still not able to do this. So I'll demonstrate it again, but I'm kind of just demonstrating what's on there. You let me know if you're still on and if this is it. But I will go to Insert, Image, Upload from Computer, or excuse me, Camera. And what that does is it turns on my webcam. So I'll click that. You'll be able to see like, hey, this is me. I'm holding up my work. Whoops. And this is actually the selecting and sequencing that I did from today. I take a picture and I hit insert. And now that like picture goes right up on the slide, which can be really nice if you're trying to show student work. You can even zoom it in. My webcam's pretty terrible, but I've got some fingerprints from my little online learners on it. But that's how that works.
Thanks for sharing that, Teresa. How does it make it a GIF though?
Oh, it doesn't turn it into a GIF. I just try to put this question into a GIF so people can copy and paste it on their slides. And it'll show the kids how to do it. I use like a GIF converter. I don't know that I have one particular one. I just Google GIF converter and I put my video in it. So Raha, all I do is just right click it and do copy and paste, or like copy and paste slide 59.
Mm-hmm.
I see. So it's a slide showing how you can have students share their work into a slide, but not how to create, like do that and then turn it into a GIF.
Right.
But you use a GIF converter to do what you're showing here.
Right. I'm just trying to showcase the directions of, because kids will be like, I don't know how to do that. So I just find that having an on repeat GIF gives them enough time to see it.
I see what you're saying. Like, here's a frequently asked question that I have given instructions for that I have to into a GIF. Got it. Okay. Thank you.
Oh, Laura, I didn't know Snagit will turn things into GIFs. I love learning new things. Thanks for not letting me get any sleep tonight.
Did you say Snagit?
Yeah, if you take a video,
Yeah, this is Lynn. I use that.
Snagit
That's what
on-
I use with mine to snag it through.
Yeah, so Raha and I do it like we'll film ourselves, like we'll record ourselves, like I will record ourselves doing directions, like if we want to teach kids how to do something on the slides. And if you record it as a video and then in Snagit editor, you can turn it into a GIF and it'll just play it, just like Teresa has, like it's just a perpetual loop. And you can add it to a slide and then kids, instead of having to watch a video, they can just watch a GIF.
You can insert it in a Google form too, which I realized if you insert a picture, you can insert a GIF in replacement of a picture, which is cool.
Wow, you can do that in a Google form? That's really cool.
Yes, yeah. You just have to make sure the GIF is saved in GIF format. Like, so you can't insert it as a picture. You have to have it saved to your drive or somewhere in GIF format, but you can even put it into a Google form. Yeah.
What I've noticed with Google Forms is that you see it different than the kids do.
Yes, but you can do preview, and do you when you're in a Google form and you see like that eye picture, like that eye icon, like a big eye, if you click on it, that you can click on it and then you can see it the way the kids would see it.
I'm going to go look at that now. Where's the eye?
In the upper right-hand corner.
Yep.
You see next to the
preview.
Yeah, the eye button is
You just totally made my whole week easier.
Oh
my God,
so
because I teach deaf kids, and so they it's really hard to Zoom with them. So I found, I signed like an ASL story, and then what I've been doing is assigning questions to the ASL story to make sure they're answering the questions. But I like to see what they're seeing, because when you put the video in, you don't know what they're seeing. Oh, that is so cool.
Yeah.
Oh, thank you
Yeah,
so much.
we sometimes, Raha and I have run into a little trouble sometimes because like if we'll put a video in, the video doesn't work for the kids, so we have to kind of test it out and see it from the way they would see it first.
That's amazing. That's great. Oh, that's so awesome. Because one time I sent it to somebody to have to look for it, or I sent it to myself. So then I had to log into my other account to look at it. And it was just such a pain in the, oh, that's so much better. Oh, thank you.
Hi, Karina.
Come to Math and learn about Google Forms.
I have an ASL question for you. You might know.
Sure.
So my daughter's name is Josephine, and she goes by Joey. And when I had, and so we're trying to come up with a name sign for her. When I taught, I had a deaf student teacher once, and that teacher gave me a name. I collect a lot of turtles. My name starts with the letter T. So now if you ever sign my name, it's actually the sign for turtle. And so I'm wondering if you happen to know if Joey, like a baby kangaroo, is signed the same way as kangaroo, or if you know if there is like a version
I don't
for
know,
Joey.
but really in the deaf world, you're supposed to not make your own sign name up. You're supposed to wait till a deaf person gives it to you. So you just finger spell your name, and you're supposed to, in the deaf world, if you want to follow deaf culture, deaf way, you're supposed to let a deaf person give you your sign name. But your question was, is kangaroo, I don't even know the sign for kangaroo. Oh my God, I'm gonna have to look at that. So say that, I think You would just say baby kangaroo.
She was really excited that, so my deaf student teacher Maria gave me my name, but it looks like turtle. And she was
Okay.
she was curious if Joey had its own sign, but I'm really excited to know about that from Deaf Culture.
I don't think so. I don't know. Yeah, it's there. It's just really cool. Like you can get yourself your own name sign, but it's really like a lot of times, like a teacher, their own. My students will make up a name sign for their deaf teacher. But I think you just say baby kangaroo for Joey.
Okay.
I'm gonna have to look at that.
And so,
I'm still
if
learning.
that's the
Like you
case,
still,
do you have a different sign for your name depending on the community that you're in? Or like once you're given that sign, do you show other people that sign?
Yep. Mm-hmm.
Cool.
Mm-hmm. Yep. So you just wait. You just you just learn to finger spell your name until you're given. Like I didn't know that I gave myself my name sign, and I hate my name sign now because it's just CG. But like, so you just finger spell your name until you meet a deaf person and then you finger spell it, and then you just say, "Oh, I not yet have a sign name," and then a deaf person will give you a sign name according to what they think your sign name is.
Oh, that's
so you just would finger spell your name until then. Yeah, it is really cool. It's really, I mean, when you think about it, the reason the deaf children's language is so low is because they don't have the connection to hearing. So it's like every word they learn, they have to memorize. They can't just look at a word like the word I'm looking at my chip bag, yummy. Oh, yummy. Oh, yummy. I know that word, yummy. You have to memorize that yummy is yummy. You don't have the connection. And that's why it's really hard for deaf children to learn to read. Or also there's many different signs for one word, or wound, like the word word wound could be wound. It's crazy.
Oh, wow.
Poor kids.
Yeah, one of
So a lot
the
of people
benefits
have
of
a hard
this
time
pandemic is
understanding that.
learning.
That's why I love these classes, because, what's that? Say that again? Sorry,
I was
what?
going to say I've been learning a couple signs for just Zoom sessions. So when I start a session, I can say like, "Hello, my name is Teresa," and actually sign that out. Since I'm sharing my video anyways, might as well. And just trying to
Yeah,
learn
I love
some
signs.
new pieces. And I especially like it when I get feedback from other people, like, turn your hand a little bit more this way, your palm out or something.
Yeah.
And it makes all the difference in the world for me.
Yeah, it's so fun. I love it. And I love this because math really sucks for deaf kids because math is so much language now. It's not about the computation of knowing how to do the math. And I love this kind of stuff because it's visual and they can do it and language doesn't get in their way. Like some of these math problems that I work out with my 5th grade math student in their math book, I have to read it 5 times to get them, So this is fun because they don't add language into math. So it's really neat. But yeah, take a sign class somewhere. They're really fun. It's the best thing to do is to learn and find a deaf ASL teacher, or go to the community college in your area and maybe take a sign class from them, But I think learning from deaf people is the best way to learn. So.
Awesome.
Did I lose? I think I might have lost connection. Nope, I'm good.
All right,
I'm up at
folks.
camp where I don't have really good internet.
I'm going to head off. This channel is open if you want to continue to chat with each other. Happy MATHurdays. And yeah, next week we've got decimal computation. So hope to see you there.
And Meg had a question. I could stay on. What did she say? Like, do you have any, wait a minute, recommendations for teaching hearing impaired students? I'm always thinking about how to help students with hearing or seeing. It just depends on their level, really, Meg, like what their reading level is. And it's just really hard to just
That's fair.
trying to realize that